1, Lesson 7, Algebraic Expressions, the Commutative and Associative Property, we're going to focus on one instructional outcome, and that is their students' ability to be able to use the commutative and associative properties to recognize structure within expressions and to prove equivalency of expressions. So when the class starts for this particular lesson, the teacher is going to bring up exercise 1/2. And in this illustration, it shows that Susie draws the following picture represented by the sum 3 and then plus 4, whereas what we're recognizing as the 3 and the 4 is that Susie has 3 boxes here, and then she added to it 4 boxes there. Well, Ben looks at this picture from the opposite side of the table. Ben's sitting over here and says, well, you drew 4 plus 3. And so this teacher is going to be asking the students, why might Ben interpret the picture as this way? Well, from Susie's perspective, she drew 3 boxes and then 4 boxes. But from Ben's perspective, he sees 4 boxes and then he sees 3 boxes. Now, when we continue to look at it, the teacher may bring up this following idea. Well, Susie decided to add more to her picture. She says, well, now the 3 plus 4 that I originally drew now has a plus 2 on it. So now she's defining it as 2 individual parts. The 3 plus 4, which was the original picture that she drew from here to here, and now she's adding 2 more to the end of that particular table. And so how might Ben interpret this picture? The students will have a chance to think about it and explain their reasoning, and Ben may consider that it is 2 and then plus before plus 3, sitting from his perspective of what he sees. Now, this lesson is about the commutative and the associative property. So, with that being our focus, there are 4 properties, 2 for addition and 2 for multiplication. First, we look at the commutative property for addition, and what we're noticing is that the only difference here is if I've got my A plus my B, then if I said B plus A, we tend to think that is the same thing. As an example, if I said 4 plus 3, that's the same thing as saying 3 plus 4. If we scroll down and look at the next one, the associative property of addition, this is where grouping symbols come into play. This is, for example, if I have A plus B in parentheses, and then plus C, and it equals the same 3 numbers, but now that B plus C is grouped. So for example, if I said 1 plus 2, let's see, 1 plus 2, I'll put that in grouping symbols, plus 3, then it would be fair to say that 1 plus the 2 plus the 3 would also be equal to the same value, whereas 1 plus 2 is 3 plus another 3 will be equal to 6. But over here, if I do 2 plus 3 first, I get 5, and I add 1 next, I still get 6. And so that's an illustration of the associative property of addition. Next, we have the commutative property of multiplication. Likewise, all we did was take the addition sign out and put the multiplication in, to where if I said 4 times 3, that would be equal to 3 times the 4. And then finally, we look at the associative property of multiplication, where if it's rearranged in the order in which it is all multiplied, you would still get the same product. Like if I did 1 times 2 times 3, and I set that equal to 1 times 2 times 3. This time the second half is grouped. 1 times 2 is 2 times 3 is 6, and 2 times 3 is 6 times 1 is also 6. It is encouraged that students take time and really study this particular note that was given in class, the difference between what it means to be commutative versus associative. We want the students to think associative has to do with grouping symbols, where commutative does not have anything to do with grouping symbols in this particular lesson. So in the notes, the teacher brings up this diagram, and we're looking at it. We see two circles, and we see our primary source, which is right here, our x plus our y plus our z. And we want to know, if we're looking at this and I changed it to z plus x plus y, did I regroup anything, or did I rearrange or swap what I had? And so when we compare it, we see the x plus y in the front and the z in the back. But in this one, we have the z in the front and the x plus y in the back. And so we are going to designate that as the commutative property, C for commutative property of addition. So if we went back and looked at it, here it is, our A plus our B equals our B plus our A, where all it is, we swapped the two pieces around to make that work out. Likewise, if we look at this right here, x plus y in grouping symbols plus the z, how did it change here? We've got the x outside the grouping symbols, and now we have regrouped it as y plus z, and that's designated as our associative property, again, of addition. And that's this property here, where you see the a plus b is grouped with the c on the outside, but in the new rendition, the a is no longer grouped, but the b plus the c is grouped. And so the teacher introduced the students to those two, and in pairs, the teacher encouraged them to then go back and look at these two additional circles, and how does it relate to this particular piece right here, the z plus the x plus y in grouping symbols, and what it will do here versus what it will appear in that perspective. So again, if we look at it, we see here the z is by itself, but over here the z is grouped. So what we did is we rearranged what was grouped. And so that will again be our associative property. And in this one here, the only difference between this one and this one is I switched the location of the x and the y. Here it says x plus y, but this one says y plus the x. And so since all we did was swap two terms around, that will be our commutative property. And again, the teacher is helping to refine and continue with the thinking process to where finally we'll add this final branch, 3 more circles, allowing the students to kind of continue to develop their mastery of the skill and thinking of what's going on. And so now we're looking to see what is happening between this x plus y plus z and this y plus z plus x. And again, what you notice is that the two terms overall were swapped or switched in this particular perspective. So this would be our commutative property. Here we see the y plus the z, but in this one the z plus the y was switched. And so that is our associative property. Whoops, not associative, the commutative. And then again, one more time, we see how here the grouping symbols have changed, and that is the associative property for this diagram. It is important students study a diagram like this. They have one in their notes, they have one that they did in small groups, and they should have one that they are doing in homework. This will be a design or a pattern that they're going to have to be able to demonstrate come the assessment. So the last exercise, exercise 7, on page 33, is a full diagram that starts with the x plus 4 plus the 5, and then in grouping symbols an a plus a 2x, and then times a y. So I would encourage you at this point to pause the video and try for yourself. Do you believe it is the commutative property for addition, commutative property for multiplication, associative property for addition, or the associative property for multiplication? And when you think you have a theory on what it may be, then you can come back and press play and see how you did in this particular design. So the answers, when we look at this, is this first one up here at the top is the commutative of addition. Now if I follow this flow through, we'll look at this one right here, would have been the commutative property of multiplication. This circle right here would be the commutative property of addition. This one right here is the associative property of addition. This one that I kind of left behind is the associative property of multiplication. And this one here is the associative property of addition. And again, it is encouraged, now that you have the answers, if you got one wrong, to go back and examine why it is what it is. Why did I choose that particular decision? In other words, if this is commutative of multiplication, what occurred to make that commutative property of multiplication? And to illustrate or show that point is this right here, the 2x times the y, compared to the y times the 2x, which illustrates that commutative property of multiplication. In closing, there's just a few thoughts. A variable symbol is a symbol that is a placeholder for a number. So if we said x, or 4x, that is a placeholder for a number. And then two algebraic expressions are equivalent if we can convert one expression into the other by repeatedly applying the commutative, associative, and distributive properties. If you want more information or more in-depth information on this, please email your teacher here at the school and we can give you some more information about commutative and associative properties if need be.